Hi, my name is Drew Pemberton, and today I'm going to teach you how to use the Atomic Absorption Spectrophotometer, or the AA for short. The first thing we're going to do to use the AA is to make sure that the acetylene gas is turned on, if it's not already. To do that, we simply open this valve on the gas tank by rotating it counterclockwise. You can see up here the needle has risen from 0 up to 15. So that means that the gas is currently on. The second thing we need to do in order to use the AA is to turn on the flame. You can see here is where the flame is going to come out. This is the igniter tip. In order to ignite the gas, we press this flashing white button. If it's not flashing, then that means that it's not ready to ignite. And this red button down here is to kill the flame once you're finished. And we simply press it until the flame has been lit. The third thing we'll need to do in order to run the AA is to load up our samples into the auto sampler. This is the auto sampler. It runs samples automatically, as the name implies. You can stick your samples in any of these 4 trays here, and then the standards should be right here. In this case, we've made up a 1 part per million solution of iron, a 2 part per million solution, a 5 part per million, a 10 part per million, and a 20 part per million. And then lastly, we have our blank, which is just DI water. So once we have our standards made up and placed into these slots here in ascending order, so the smallest concentration should be first and the largest concentration should be last, we can then put our samples into the auto sampler wherever we would like. It doesn't matter as long as we tell the computer where it's supposed to be. This is the extraction tip. It pokes itself down, sucks up liquid. The liquid goes and runs into the AA in order to be run through the flame. And it's important to remember, make sure you take the vials tops or the screw tops off of your vials, and then once you're finished with them, make sure you replace them. Otherwise your sample could evaporate and then it'll no longer be at the concentration that you've said it is. Now we are ready to set up our method and analyze our sample. So you can see here that we've started our sample analysis, and right now it is purging, I believe. So it's running it through the flame in order to get ready to run our standard samples. So you'll actually see over here to the left, these containers need to be hooked up, and these are just waste, I believe. So now, right now, the auto sampler is looking at the blank, so it's drawing up some solution. And now it's moving on to the second one. So with these samples, or these standards rather, these standards will be run through the AA twice. We can even open the door here so we can maybe see the flame a bit. So I don't know if you can hear that clicking noise. There it is again. That clicking noise is just to indicate that, oh, it's running a sample. So that clicking noise happens every time something runs through the AA. So the auto sampler is drawing up solution. It's going to pull it out, run it through the AA, and from those standards, then we'll be able to make a calibration curve, and then we'll be able to analyze our unknown samples and know what the concentration is based on that calibration curve. And this process, depending on how many samples you have, can take at least 5 minutes. So we'll check back once it's all finished. So in order to run the AA, we need to open up Solaire. This is the interface program that communicates with the AA instrument, and it's what allows us to be able to look at our results. So first thing we're going to do is we're going to create a new method, and then eventually we'll run an analysis once we've set up our method. So go ahead and click on that. Most of these settings, you're not going to have to change from the default. You'll just go ahead and do it as is, but I'll point out the ones that you are going to have to change. So our method name, we'll call it Iron Standard Test Run. Next. So we just put in 2 samples in there. We do have an auto sampler. It is the CTAC 520 and rack code. So that's just how many vials are in each rack, or how many spaces for vials. So in this case we've got C60 in all of them but the last one, but that doesn't matter because we're not going to be worrying about the last one. Next. From here we can click on any element, well, almost any element. All of the ones that are colored are ones that you can run. This just tells the gas mix that you should use to run that sample. So in this case we're running iron, and you can run more than one metal. You'll just have to set up your standards to be a mixed standard, so like it has chromium as well as iron as well as lead, let's say. So next, we don't need to mess with that. Normal number of standards, so we have 5 standards. The first one is at 1 milligram per liter, which I believe is part per million. The next one is 2. Next one's at 5, 10, and 20. Would we like to add another element? If you were running more than one element, then you would check yes. In this case, we are just running 1, so we can leave it at no. And this is just a summary, blah, blah, blah. Yes, we would like to save it. And yes, we'll save it as that. So click on the Analysis Wizard button if you wish to run your method now. So that's our method. On the View tab, we would want to go to ASLG. That's the Auto Sampler Loading Guide. And so we're going to set up where our samples are at. So to do that, you can just click on your sample, and we can click and drag it to whichever position we've loaded it into the auto sampler. So we have it as sample 1 and sample 2. and I actually set those up to be about 15 parts per million, and about half of that, so 7.5 parts per million. So we have our first standard is blank. This one is standard 1, which is the 1 parts per million, 2, 5, 10, and 20. So now that that's good, we can hit close, and we can analyze our stuff. Okay, we are back, and we are ready to look at our results. So right now, it doesn't have concentration calculated. That's because we don't have a least squares fit. So we'll change the line fit. You could do linear least squares, which works pretty well. So I had made up the first sample to be about 15 parts per million, and the second one to be about 7.5. So this is pretty close. The reason why it's giving you red, or these are in red when they were before in black, is because simply the program doesn't think that it doesn't think it's as accurate as it ought to be. So the R² value is 0.9940, which is pretty good. That's pretty good. But since our AA is very precise, we can get better than that. So look at that, 0.9986. And now it's given us corrected concentration of about 15.25 and 7.26, which is pretty close. So that is all there is to running an AA sample. The last thing you need to do before being done with the AA, there are no more samples to run. Go ahead and turn off the flame, and you do so by pressing and holding this red button. So you see that the flame went out, and we press and hold it in order to purge it, and then we can go and turn off the gas. The second to last thing, almost the last thing we gotta do, is shut off the gas. And finally, the last thing we need to do is to put the lids back on our standards. Otherwise, they will evaporate and will no longer be the concentrations that they are labeled to be. So if I wouldn't put the lid back on the 20 parts per million standard, it'll evaporate, and then it could be 100 parts per million, and I wouldn't know that. Or I wouldn't know the exact concentration. So this ensures that the concentration remains the same, and we can use it again. And now we are done. The only thing that you would want to do is probably get rid of your samples, dispose of them in the proper waste containers, as always.